Today we'll be tackling simple strain, specifically axial deformation. So here's a problem. The rigid bar AB attached to two vertical rods as shown in the figure below is horizontal before the load P is applied. Determine the vertical movement of P if its magnitude is 60 kilonewtons. So to solve this problem, first we need to get the free body diagram of the figure. Since there are two unknowns, the most optimal way to find these is to get the moment of forces along A when clockwise is positive. So here we have C going clockwise, which is positive, while the P of steel is going counterclockwise, which is negative, thus making a equation for steel is that. This will lead us to having 40 kilonewtons for the force applied by steel. Then we would use the deformation formula, plug in all the details. 40 will convert 40 kilonewtons into newtons. The 4,000 would be converted into millimeters. The 200,000 would be converted to megapascals, and we will have an answer of 2.67 millimeters. And to get the same thing, we have to repeat the same process to get the force of aluminum. But this time we would get the moment along P, where clockwise is positive. So this time the force of aluminum is clockwise, while the force P is counterclockwise, which makes it negative, which will lead to an equation of this. So the force of aluminum would be 20 kilonewtons. Again, we would use the deformation formula to find the deformation of aluminum. Once that is finished, the values we got is the deformation caused by the two rods, and this would be the result since steel has a longer elongation. This would be longer than aluminum. Then the figure would look like this. So since we're looking for the vertical movement of the force, which would be this, we still cannot find the figure since we need to find the values of y, since this part is already 1.71 millimeters. So since these are similar triangles, we can use the equation of this, and then this will lead us to 0.64 mm. But that is just the distance traveled from this point to the new figure of the new outlook of the bar. So to get the total vertical movement, we should just add the 1.71 mm plus our y, which would lead us to a deformation of 2.35 millimeters.